Mars, the red planet, a place where dreams and nightmares collide. For centuries, it has been the canvas of human imagination, a world painted with the colors of mystery and intrigue. But beneath its dusty red surface lies a tale far darker and more enigmatic than we ever dared to dream. Imagine standing on barren, frozen plains, feeling the cold Martian wind whisper secrets from a time long forgotten. A time when rivers carved their way through the desolate landscape, leaving behind ghostly traces of their existence. The ancient river valleys of Mars are not just dry channels cut into rock, they are silent witnesses to a lost world, a world that we are only beginning to understand. These valleys, with their sinuous paths and winding courses, suggest a planet that was once alive with the flow of water. The evidence, etched into the Martian crust, speaks of a history that is both fascinating and deeply enigmatic. But what happened to this water? Where did it go and why did it vanish? As we peel back the layers of Mars's geological history, we uncover a tapestry woven with threads of mystery. Each discovery brings us closer to understanding a planet that once might have been more like Earth. With every new piece of data, scientists are reconstructing a story that is as captivating as it is eerie. The march of time has left its mark on Mars, and it is up to us to decipher the secrets hidden in its ancient river valleys. The story begins with the whispers of water. For decades, robotic explorers have roamed the Martian surface. Images reveal winding channels and dried-up riverbeds. These features hint at a wetter past. The idea is both thrilling and unsettling. How did a dry planet once harbor dynamic water systems? Curiosity, opportunity, and perseverance symbolize our pursuit of knowledge. Each mission uncovers clues of ancient lakes and rivers. The discoveries paint a picture of Mars that is both familiar and alien, a planet that might have been home to vast networks of rivers and lakes. Yet the deeper we dig, the darker the story becomes. The ancient river valleys hint at a dramatic change, a change that left behind a dry and desolate wasteland. What caused such a transformation? Was it a gradual climate shift or something more catastrophic? The answers lie buried in the Martian soil. As we explore, we come closer to unraveling the mysteries. Each discovery brings us closer to understanding Mars's dark past. The journey is far from over, and the secrets of Mars are waiting to be unveiled. The quest to unravel Mars's enigmatic past began long before our advanced technology could touch its surface. Early telescopic observations by Giovanni Schiaparelli in the late 19th century sparked imaginations worldwide. But it wasn't until Mariner 4's flyby in 1965 that we glimpsed the red planet's true cratered face. The Viking missions of the 1970s provided the first detailed images of Mars's surface. These images revealed valleys and channels resembling dried-up riverbeds on Earth. Suddenly, the idea that Mars could have had water and possibly life became more plausible. The dawn of discovery was just the beginning. Mars orbiters have played a crucial role in mapping ancient river valleys. The Mars Global Surveyor, launched in 1996, provided high-resolution images of the Martian surface. Its data revealed intricate networks of valleys, clear evidence of liquid water reshaping the landscape. The Mars Reconnaissance Orbiter uncovered detailed images of river delta formations. These formations are strikingly similar to those created by water on Earth. Mars's ancient rivers were part of a dynamic and complex hydrological system. Orbital data has guided subsequent missions, pinpointing areas of interest for closer examination. While orbiters provided a bird's-eye view of Mars's ancient river valleys, rovers offered ground truths that transformed our understanding. Opportunity made groundbreaking discoveries in Meridiani Planum. Curiosity landed in Gale Crater in 2012, exploring ancient river valleys. Perseverance, the most recent rover, landed in Jezero Crater. It searches for biosignatures, uncovering Mars's watery past. These rovers collect invaluable data, revealing Mars's ancient river valleys. The ancient river valleys of Mars are geological archives holding secrets to the planet's past. By examining these features, scientists have uncovered clues about Mars's climatic history. Stratigraphy reveals layers of sediment that tell a story of water, wind, and volcanic activity. The presence of clay minerals suggests that liquid water was once widespread. Analyzing these minerals offers a glimpse into Mars's wetter past. The valleys' branching patterns and layered deposits point to prolonged water activity. These features indicate a range of hydrological processes on Mars. Each discovery helps build a comprehensive picture of Mars's ancient environment. Mars's ancient river valleys are not just geological features, but chapters in a larger story. These valleys, with their intricate patterns, offer a window into a time of flowing water and dynamic landscapes. Valles Marineris, a colossal canyon system, dwarfs the Grand Canyon on Earth. Within its depths lie clues to Mars's geological past, including ancient river channels. Valley networks in Margaret-Typher Terra resemble river systems on Earth. They suggest a time when rain or snowmelt fed these rivers. As we take a closer look, we see Mars's dramatic transformation. The valley's sinuous paths and eroded banks tell a story of a planet once alive with water. These valleys are the key to unlocking Mars's mysterious past. The search for life on Mars has long tantalized scientists and enthusiasts alike. As we examine the ancient river valleys, the question of whether Mars once harbored life becomes ever more pressing. Fossilized possibilities, traces of ancient microbes could be hidden within the Martian rock. If life ever existed here, it would have left behind subtle markers, organic molecules, specific mineral formations, or even microfossils. In Gale Crater, curiosity has uncovered organic molecules in sedimentary rocks, hinting at the presence of ancient life. These molecules, while not definitive proof, are tantalizing clues. They suggest that the building blocks of life were present when water flowed through these valleys. It's a discovery that raises more questions than it answers, pushing scientists to look deeper and more meticulously for signs of past life. The search for fossilized life extends to Jezero Crater, where Perseverance is exploring an ancient river delta. Deltas on Earth are rich in organic matter, often preserving the remains of ancient life forms. The hope is that similar processes occurred on Mars, trapping and fossilizing microbial life within the delta's sediments. The rover's instruments are capable of detecting biosignatures, subtle chemical fingerprints that life might have left behind. These traces of life, if found, would not only revolutionize our understanding of Mars, but also our place in the universe. Finding even the simplest life forms on Mars would suggest that life is not unique to Earth. It would imply that wherever conditions are right, life can emerge. The implications are profound, opening up new avenues of exploration and challenging us to rethink the very definition of life. To understand Mars's ancient river valleys, we must explore its past climate. Mars's current thin, cold atmosphere can't support liquid water, yet evidence shows rivers once flowed. One theory suggests Mars had a thicker carbon dioxide-rich atmosphere, creating a greenhouse effect. Carbonates in Martian rocks support this idea, indicating the presence of carbon dioxide and water. Volcanic activity or impacts from comets and asteroids might have periodically replenished the atmosphere. These impacts could have created transient periods of warmth and stability, explaining the ancient river valleys. Mars's loss of its magnetic field allowed the solar wind to strip away its atmosphere. This atmospheric escape transformed Mars from a warm, wet world to a cold desert. Understanding this transformation helps us learn about atmospheric processes on other planets, including Earth. The climate conundrum of Mars is a key to unraveling its past and potential for life. The possibility of microbial life on Mars drives many scientific investigations. Mars's ancient river valleys are prime locations for finding evidence of such life. Microbial life could have thrived in Martian groundwater, even after surface water disappeared. Recurring slope linii, RSL, suggest briny water may still flow intermittently today. Earth's extremophiles, thriving in harsh conditions, support the idea of life on Mars. Microbial life on Mars could have left fossilized remains or chemical signatures in riverbeds. Isotopic ratios in Martian rocks can indicate biological activity, such as a preference for lighter isotopes. Analyzing these ratios in Martian samples helps infer past biological processes. This multifaceted approach combines direct searches for microfossils with isotopic analysis. The search for microbial Martians continues to uncover the potential existence of past life on Mars. The Great Drying marks Mars's transition from a wet world to a dry desert. The loss of Mars's magnetic field allowed the solar wind to strip away its atmosphere. This atmospheric escape reduced surface pressure and temperature, drying up ancient river valleys. Volcanic activity initially warmed the planet, but later contributed to atmospheric thinning and cooling. Impacts from asteroids and comets caused temporary heating, but also atmospheric loss. Large impact basins like Hellas Planitia support this idea. Understanding the Great Drying offers insights into planetary climate change. Studying Mars's water and atmosphere loss helps us learn about processes affecting other planets. The mystery of Mars's ancient river valleys reveals the dynamic forces shaping planetary environments. Unraveling this mystery is key to understanding Mars's evolution and potential for life. Mars's ancient river valleys offer profound insights into planetary evolution and environmental change. Studying Mars's past teaches us valuable lessons about Earth's climate change, water cycles, and potential for life. Mars's transition from a wet world to a dry desert highlights the importance of a stable atmosphere. Earth's magnetic field and atmosphere protect us from solar wind and cosmic radiation. Understanding Mars's atmospheric loss informs us about our own planetary shield's vulnerabilities. Mars's river valleys emphasize water's role in shaping planetary surfaces and supporting life. The search for past life on Mars encourages us to consider life's resilience in extreme environments. If life existed on Mars, it likely adapted to harsh conditions, expanding our understanding of life's potential. Exploring Mars helps us address environmental challenges on Earth. Mars's ancient river valleys are a testament to the dynamic nature of planetary environments. Imagine standing in a Martian river valley, now dry and barren. These valleys were once filled with water, but the rivers have vanished. Recent studies suggest Mars's water may still be trapped beneath its surface as ice. The rivers didn't just dry up, they were erased by dramatic climate shifts. Volcanic activity or asteroid impacts could have rapidly cooled the planet, locking its water away. Mars's atmosphere was slowly stripped away by the solar wind, causing the rivers to dry up. This gradual loss left Mars a barren, dry landscape. The disappearance of Mars's rivers is a haunting mystery. Exploring these ancient river valleys reveals the dramatic changes that shaped Mars's history. Mars's rivers, once vibrant and flowing, are now mere shadows of their past. Picture Mars billions of years ago as a world brimming with life. Rivers snake through fertile plains, feeding into vast lakes and seas. The atmosphere is thick and warm, nurturing an ecosystem that thrives in the Martian soil. But a series of volcanic eruptions shrouds the planet in ash and gas, plunging Mars into a cold winter. A massive asteroid strikes, vaporizing rock and water, destabilizing the atmosphere. The rivers freeze, their water turned to ice or vaporized and lost to space. Mars transforms from a warm, wet world into a cold, arid desert. The rivers, lakes, and seas are gone, leaving behind only scars on the planet's surface. This hypothetical scenario encapsulates the events that might have led to Mars's water disappearance. It underscores the fragility of planetary environments and the forces that shape their destiny. The Martian chronicles are written in stone, telling a story of dramatic transformations. Sulfates and perchlorates in the soil suggest Mars's water was acidic and salty. These harsh conditions challenge life, but are not impossible for certain extremophiles. Mars's rapid climate shifts are evidenced by ancient glaciers and ice flows interspersed with river valleys. Volcanic activity, asteroid impacts, or variations in Mars's orbit and axial tilt drove these cycles. Isotopic analyses indicate Mars's atmosphere was once denser, supporting liquid water. The solar wind stripped away lighter elements, thinning the atmosphere and cooling the planet. This atmospheric escape left Mars vulnerable to harsh conditions, sealing the fate of its ancient rivers. The Martian chronicles reveal the dynamic and often violent history of the Red Planet. Each discovery brings us closer to understanding the forces that transformed Mars. Imagine a time when Mars was home to a thriving civilization. This civilization harnessed the power of water to build cities and develop agriculture. The ancient river valleys were vital lifelines of a complex society. The Martian civilization flourished for thousands of years, thriving in harmony with their surroundings. But volcanic eruptions, asteroid impacts, and atmospheric loss wreak havoc on this civilization. The rivers dry up, the climate cools, and the once fertile land becomes barren. The Martian people face extinction, their cities abandoned, and their stories forgotten. This speculative history serves as a reminder of the fragility of civilizations in the face of planetary changes. It draws parallels to our own world, where environmental shifts can dramatically alter human history. The idea of a lost Martian civilization adds depth to the mystery of Mars's ancient river valleys. Mars's echoes of a forgotten era. The ancient river valleys of Mars stand as silent witnesses to a forgotten era. Their winding paths and eroded banks echo with the stories of a time when water flowed freely. We are listening to the echoes of Mars's past. Each valley tells a unique story. Some speak of slow rivers, others of catastrophic floods. These features are like pages in a history book. By studying them, we piece together Mars's dynamic past. The silent witnesses hold clues about Mars's water. They point to significant climatic shifts. These clues help reconstruct ancient Martian climate. The silent witnesses are keys to understanding Mars's history. Each discovery brings us closer to unraveling Mars's mysteries. The echoes of Mars's forgotten era resonate with stories of change and transformation. They remind us that planets are shaped by nature and time. We are learning about the processes that shape all planetary bodies. The silent witnesses stand as enduring symbols of Mars's enigmatic nature. Bridging Mars and Earth, the quest for knowledge. The ancient rivers of Mars hold the keys to understanding planetary evolution and the potential for life beyond Earth. Each discovery in the Martian soil echoes with implications far beyond the red planet. The parallels between Mars and Earth are striking. Both planets have experienced dramatic environmental changes. Studying Mars's river valleys offers insights into planetary surfaces and the role of water in fostering habitable conditions. Mars's ancient river valleys remind us of our place in the cosmos. Bridging Mars and Earth, our quest for knowledge is a shared endeavor. Mars's ancient river valleys offer profound lessons for Earth's future. Mars, once vibrant with rivers, now reminds us of planetary fragility. Its transformation to a barren desert holds crucial lessons for Earth. Atmospheric loss on Mars underscores the importance of a stable atmosphere. Mars's river valleys highlight water's role in shaping landscapes and supporting life. Protecting Earth's water resources is paramount. Mars's lessons prompt reflection on our relationship with the environment. Section 3. Charting the path forward, exploration and preservation. As we look to the future, the exploration of Mars's ancient river valleys continues to be a guiding light. Each new mission adds another chapter to the story of the Red Planet. It enriches our understanding of Mars and informs our approach to exploration and sustainability on Earth. Future missions will build on the foundations laid by pioneers like Curiosity and Perseverance. Advanced technologies will provide unprecedented insights into the planet's geology and climate history. The exploration of Mars emphasizes the importance of international collaboration. Collaborative efforts enhance our ability to conduct comprehensive investigations. Preservation is critical. We must protect Mars's pristine environments. Charting the path forward involves a commitment to sustainable exploration and responsible stewardship. The ancient river valleys of Mars are a testament to the planet's dynamic history and potential for life. As we explore Mars, we deepen our understanding of the cosmos, embracing exploration, preservation, and sustainability.